In this video, I will explain how Java programs are compiled and executed. And also I will explain how Java programs are platform independent. Whereas the programs of languages like C and C++, they are platform dependent, but Java is platform independent. So let us learn how Java programs execute. See, already in the demonstration videos, I have shown you we have to write a program file, that is first.java. We have written this program file, right? Then we use Java C for compiling our program. So this file is called as source code, right? Source file or source code, because here we are writing Java code. Compiler will read this source code and confirm that it is error free. If there are no errors, then it will generate a class file, first.class file, and this file will not have machine code, but it will have bytecode. It will have bytecode. So Java compiler will convert a source code into bytecode. So this bytecode is not a executable program, but this is error-free program. It is not having any errors. Then how Java program can execute? Bytecode will not execute. Then how it will execute? For execution, we call Java, that is nothing but we call JVM, and we ask JVM to execute this file. So JVM is Java Virtual Machine. What does it mean by Java Virtual Machine? So for just basic understanding, you can think that the laptop or PC that you are using is a machine, and within that there is a virtual machine. It's not a real machine, it's a virtual. This virtual machine will have an interpreter or JIT compiler. It will also have JIT compiler. This is called as just-in-time compiler. So interpreter or JIT compiler that will convert this bytecode into machine code and get it executed on the hardware. This is the hardware. I have not shown it in the picture. It will get it executed on the hardware. Can JVM directly interact with the hardware? No, it will interact with hardware via operating system. Not directly, but via operating system. So JVM will talk to operating system, and operating system will help JVM to get its program executed. Okay. So how about other languages? Let us say this is a C++ program. C++ program. First.cpp. When you compile, we get first.exe, and this is nothing but machine code. This is machine code. The CPP program that we have written, this is a source code. And when you compile, we get machine code. So this machine code can directly execute on the hardware. Yes, it doesn't need any conversion. Yes, it doesn't need any conversion. But no program will directly execute on the hardware. Every program runs via operating system. This machine code will be executed via operating system. Alright. See, on Windows or on our laptop or mobile phone, whenever we want to run any application, we just touch it or double click it. So who will open an application and run it? Operating system will get it executed. So programs execute via operating system. So this means this machine code can talk to this operating system, and operating system will help this machine code to execute. That's all. I have explained you how Java programs execute, where JVM is involved, and how other language programs execute. Now let us understand how Java is platform independent. See, I'm using the same diagram. See, this is my program, first.exe. Suppose this is a C++ program. I have compiled it. Now when I want to run, I should execute it over the operating system. So operating system will help this program to run over the hardware. So this program will talk to operating system. So how a program can talk to operating system? So for example, if a program has to print something on the screen, program has to print something on the screen. Let us say hello. Program cannot directly print anything on the screen. It will hand it over to operating system. Operating system will get it printed on the screen. Just a simple example I am giving you. So any program which is executing will not use the resources directly, but use them via operating system. So for getting something printed on the screen, it has to ask the operating system to get it printed. Okay. So how this program interacts with operating system? So the way it interacts, it is called as, listen to this carefully, system call. These are called as system call. So a program will make system calls of operating system to get its work done. Just imagine that you are staying in a 7-star hotel, right? And there you are staying in a suite or in a room. Then for any service, just you have to dial a number or ring a bell, and the service will be provided to you. So whatever the options or numbers that you are calling, that are nothing but system calls. Like you want room cleaning service, you make a system call. You want some food or water, then you make a system call. You want laundry, you make a system call. So you cannot do anything by yourself. It's not your home. That hotel is not your home. So you have to make a system call to get your work done. So same way, operating system will have system calls, and the program will call system calls, and that will perform operations. That's it. So here, coming to Java, this is bytecode. It cannot directly talk to operating system. It will talk via JVM. So JVM will interpret the program and execute. So JVM will talk to operating system. JVM will talk to operating system. JVM can understand bytecode and it can talk to operating system. Now coming to the next diagram. See this picture. Here I have Java program. This is the clear picture how Java is platform independent. This is our Java program. When you compile, you get first.class. This is bytecode. This is bytecode. Okay. Intermediate code. It is not direct machine code. Code cannot directly interact with the operating system. It's not a machine code, so that it cannot execute it directly, right, via operating system. It will be executed by JVM. JVM will talk to operating system. So can JVM understand bytecode? Yes, it can understand bytecode, and it will get it executed via operating system. So what is this operating system? Windows. Now same bytecode, can it be understood by this JVM running over Linux? Yes, it is possible. Then same bytecode, can it be understood by or interpreted by JVM running over Mac operating system? Yes. So bytecode is same. It can run on various operating system, provided JVM should be there on that particular operating system. JVM should be there. So who will make system calls to the operating system? Who will talk to operating system? JVM will talk. This JVM will talk to Linux. This JVM will talk to Mac. This JVM will talk to Windows. All these JVMs are same? No, they are not same. This JVM understands bytecode and can talk to Windows. This JVM understands bytecode and can talk to Linux. This JVM can understand bytecode and can talk to macOS. So this is how Java programs, once they are compiled, once you compile them, you can run anywhere. From Java that write once, run anywhere. So write one means write and compile. That means not just write and compile. Once you write and compile, that you run anywhere. What you require for running on any machine, you require JVM. That is dependent on the machine. Bytecode is not dependent, but JVM is dependent on the machine. JVM is dependent. So who makes Java programs platform independent? Means operating system independent. Who make it? JVM make it platform independent. And bytecode is common. So bytecode plus JVM, you can say, they make the Java programs platform independent. They can run on any platform. That's it. I have explained how Java is platform independent. Now let us see one more thing. Does it mean that if I write a C++ program and compile it over Windows operating system, I cannot run this file on Mac OS? Yes, I cannot run it. But if I compile this Java program on Windows, I can run it on Mac OS. Yes, I can run it. So this is possible. This is not possible. A program compiled over Windows cannot run on Mac, right? Over Windows cannot run on Macs, whereas a Java program compiled over Windows can run on Mac, and if it is compiled on Mac, it can run on Windows. Either way. But in C++, it is not possible, because if you're compiling for Windows operating system, then it is dependent on the Windows operating system, because it will have the system calls of Windows operating system. If same program, if you compile over Linux, then you get some executable code, executable file. Let us say first is the executable file. Then this will have the system calls for Linux. System call for Linux. Now same file, if you run over Windows, it will not run, because this is having system calls of Linux. When same program is talking to Windows, Windows cannot understand it. That's it. So I will give the demonstration of this in the next video. I will give the demonstration. I will write one program, C++ program, and I will show you if it is compiled over Windows, it cannot run in Mac. Now same Java program I will compile on Windows and I will run it on Mac. So don't miss the next video. There I will show you how Java is platform independent. I will give the demonstration, and how C++ are not platform independent. So that's all in this video.